Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 7-4 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to factor out the greatest common factor. Alrighty, so this is starting out by asking why it's helpful to factor out the GCF from a polynomial. We'll get into that. But let's start by actually finding the GCF, okay? So in this case, I know that one of my that my GCF here is going to involve an x, right? Because these all have x's. And the minimum number of x's is 1. So I know that my GCF is going to be an x of some sort. Now let's check out these numbers, all right? 12, 18, and 27. Those are all divisible by 3. Now if I divide those by 3, I would have a 4, all right? And 4 doesn't go into 27. So 3x is my GCF. Okay, now I can break this up using the factor tree if you want me to. I could show you it's negative 3 times 2 times 2x cubed. Like that might make it easier for some of y'all. And then the 27, 3 times 3 times 3x. So that 3x, okay, I just mentally showed you how to walk through this. But we found the 3 in all of these. And we found the x in all of these, at least one of the x's. Okay, but see how there's only 2's here and 3's there, so nothing else matches. So when we're factoring out the GCF, the reason why I came back, I stutter-stepped and came back to show you this, was because to factor out a GCF from a polynomial means that you take it out. And remember how on our last example I said here, for example, 4 and 5 were factors? They're multiplied together to make that product. So when we use the verb factoring, what they're saying to do is to split it into the two things being multiplied together. All right, now the GCF is one of the factors, and whatever's left is our second factor. So what I did was I broke this apart, and then the stuff that was left over is going to stay inside the set of parentheses, essentially. So I have a negative 2, 2, and x squared. So that would be negative 4x squared. For the blue, what's left? I have 3 times 2, which is 6. And I still have an x there, so plus 6x. And then for the yellow, I have 2 3's. So 3 times 3 is 9. So there we have kind of our GCF. Now, in this case, they want us to go ahead and they want us to pull a negative out for that GCF. Okay, now the reason why is usually we don't like having a negative in front of our largest exponent, if that makes sense. So my largest exponent here is a square, and I don't like having a negative in front of it because that makes it a pain in the neck to factor later on. So all that I'm going to do is I'm going to pull out that negative, and I'm going to change all the signs here. So see how it causes that to flip? Now what's neat is here we have this nice little pattern. Do you see how 4x squared is a perfect square? It's 2 times 2 and x times x. And 9 is a perfect square. It's 3 times 3. But watch this. 6 divided by 2. Oh, I guess that's not a perfect square. What I was thinking it might be following, which is going to make me look goofy here. I was thinking it was maybe going to follow this pattern, which is a squared plus 2ab plus b squared. Although I guess this would be a minus with this formula, right? So what I was looking for, we had our perfect squares. And so what I was looking for here in the middle was to see if we had 2ab. So a is 2x and b is 3. So I had ab, but I didn't have 2ab, which is what I wanted. I think that Savvas was trying to do that, and then they missed. They kind of dropped the ball. But there we have it on that one. That's how you factor out the GCF. Okay. Um, let's try this one. So on this one, all of my factors here, I have a 1. Okay, so because there's nothing else in front of x cubed, just a 1, my GCF is just going to contain the number 1 as a coefficient. So the only thing I can rely on for a GCF here would be the x's. So the smallest number of x's here is just that x. So my GCF in this case is just x. And so now I'm going to go to each term here, and I'm going to put what's left, right? So if there's 3 x's here, and I'm using 1 here, that means there's an x squared here. Another way to think about it is x cubed divided by x is x squared. So here I have 5xx, so if I take one of those x's away, I have 5x, and then minus 22. Alright, so now on this next one, oh, these are kind of ugly. But if I look at it, 20 is the same thing as 4 times 5, right? 28 is 4 times 7, and 16 is 4 times 4. And 5, 7, and 4, there's nothing else in common with those. So I know I could pull a 4 out. Now my highest exponent here is the 6, and it has a negative in front of it. So the GCF I'm pulling out is going to be a negative 4. And then if I look at y's, my smallest number of y's is y cubed. Alright, so let's look at this. So negative 16 divided by negative 4 is a positive 4. And if there's 6 y's here and I'm using 3 of them, that leaves me with a y cubed. Alright, now the middle term. 28 divided by negative 4 is negative 7. And if there's 4 y's and I'm using 3, I'm still left with a y. And then negative 20 divided by negative 4 is a positive 5. And y cubed, all my y's are used up. And there it is. Alrighty, so that is how you factor out the greatest common factor. Until next time.